Hello guys, welcome back to my channel, Mason African Motives, still working on mathematics N3. So in this platform, we have the question paper which was written in July 2022 that we are going to focus on. That is the X paper from Netted Engineering. So as we know, as usual, the first thing is supposed to work on the instructions, the information, make sure that you read your instructions that you're given. So without wasting much time, we are going to focus with the question 1 of the paper, where we are being told to factorize the following completely where necessary and simplify the answer. So that is to factorize completely the given expressions. So as we know that if we are given 4 terms, just like this part, we've got 4 terms in the expression. The first thing is to check if we can be able to factor out what is common from the 2 expressions that we have. So in this case, we can actually work out the first 2 and see that do we have anything common. If we do not, we move on to the other part and cross-check for the other part. But in this case, we have got 2, which 4, which is common from this part. So let's try to factor out 4 and see what we are going to have from this expression. So this is 1.1. If we are to factor out 4, this is going to be 4 divided by 4. We are going to remain with the square root of a. Minus 8b divided by 4 is going to give us minus 2b. Then from this part, we have got 6, which is common, 6x. Here we also have, we can factor out positive 6x. So let's factor out 6x and see what you're going to have. Factoring out 6x, we are going to remain with the square root of a minus, if we factor out 6x here, that's 6 divided by 12 divided by 6, which is 2. X and x will cancel. That means we are going to remain with 2b. So the 2 brackets are the same, square root of a minus b, square root of a minus b. So that means we can have square root of a minus 2b into the other part. We are going to remain with 4 plus 6x. All right, so if we are to check, yes, we have managed to factorize, but in this bracket, we've got 2, which is common. We've got 4 and 6. 2 is common here, so that means we can factor out 2. If we are to factor out 2 here, we are going to remain with 4 divided by 2. That is 2. 6 divided by 2, that is 3. So it is going to be 3x. Into this part, we are going to remain with square root of a minus 2b. So as we can see, this is the simplest part that we can actually leave our answer in. So there are actually so many ways that we can be able to simplify this expression that we are having. There are so many ways that we can use, but in this case, that can be the easiest way. So you can even try to rearrange your expression as long you have got 2 terms which are common. Then you can be able to factorize the given expression. On 1.2, we are now given f of x, which is equivalent to x cubed plus 4x squared minus x plus 3. And there we are asked to determine the remainder of f of x if it is divided by 2x plus 1. Whenever we are given a remainder, to find a remainder, what we simply have is to find the value of x when this expression is equal to 0. So that is what we have. That will be the remainder, the function that we are having. So we are going to equate 2x plus 1 to 0. So which means x is going to be negative 1 over 2. If we transpose this, it's going to be negative 1. Then you divide by 2. So when x is minus a half, that is where we are having the remainder. So we are actually referring to as the remainder is equivalent to f of minus a half. So by finding f of minus half, we are finding the remainder of the given expression. Just like if we are finding a factor, this is the same thing that we simply have. So f of minus half simply means in place of x here, we are going to substitute negative half. So that's negative half to the exponent of 3. We've got plus 4x squared, which is plus 4 into negative half to the exponent of 2. minus x, which is minus half, plus 3. So this is the given expression that we have. So we can simplify from our calculator. That's negative 1 over 2. Negative 1 over 2, everything to the exponent of 3. And now from this part, we've got plus 4 into negative half to the exponent of 2. So that's negative half, everything that we have to the exponent of 2, minus a bracket. We've got a half in this case, negative half, plus 3. So this is the given expression that we have, which is going to give us 35 over 8. So 35 over 8, that is the remainder that we are having. So we can have this as a mixed fraction, as an improper, or you can even leave it like that. So there's so many ways that you can have, but that is the remainder of the given expression. Okay, let's check the other part, which is 1.3. We are now asked to simplify the given expressions. The first part, we are given a normal exponential expression that we are supposed to work with. Okay, so let me just remove this part here. All right, so this is the question. I'm just going to rewrite our question here so that we can be able to simplify this together. 1.31, we have got 2 by 3 to the exponent of 2x plus 3 to the exponent of x. So what is actually important is for you to factorize this type of an expression. So for you not to have mistakes that you can do in this case, you can introduce a certain expression in place of 3 to the exponent of x that you understand. So in this case, I can just introduce, let in this case 3 to the exponent of x be equal to y. So I'm introducing a certain constant. It can be any letter of your choice that you want. So that means in place of 3 to the exponent of x, we are going to substitute y. So in this case, let's check this part. We've got 2 by 3 to the exponent of 2x. 3 to the exponent of 2x is same as 3 to the exponent of x to the exponent of 2. If you multiply x times 2, you get 2x. So that means in place of 3 to the exponent of x, we are going to replace with y. So it's going to be y squared. So this is going to be 2y squared. In place of 3 to the exponent of x, we've got plus 3 to the exponent of x. We are going to replace with y minus 3. There is no x, so we just write as it is. Everything over 3 to the exponent of x, which is y. So it's going to be y minus 1. So this is what we can have from this part by introducing y in place of 3 to the exponent of x. So in this case, what you're supposed to do on the numerator here, you're supposed to factorize. So from your factorization, you can obtain the expression 2 brackets, definitely. So you've got a 2y squared plus y minus 3. How do we factorize this expression, guys? As you can see, the coefficient of y squared is not 1. So that means we have to apply the longer way of multiplying the first term to the last term. 2 times negative 3, that's negative 6y squared. And we've got 2 terms that we need multiplied together must give us minus 6, but when added, we must get the middle term, which is 1. So which two numbers are we referring? That's 3 and negative 2. If we multiply 3 and negative 2, we can actually have a negative 6. If we add this part, if we add 3 plus minus 2, if we add these two together, we are going to obtain positive 1. So these are the two that you're going to use in the middle term. So it's going to be 2y squared plus, we've got 3 and minus 2. So in this case, I'm going to write this as I'm going to start with minus 2. Even if you start with plus 3, it's fine. But since I'm having 2 on the first term, I can also write with this one with 2. So it's minus 2y plus 3y minus 3. Okay, what is common? From the first two terms, we've got 2y, which is common. So if you factor out 2y, you're going to remain with y minus 1, because we've got 2 and 2 cancel, y and y squared and y, that's y. 2y and 2y are the same, so you're going to remain with negative 1. From these two brackets, we're supposed to factor out again what is common between 3 and 3 here. 3 is common, so you can factor out plus 3. If we remove 3, you're going to remain with y minus 1. So as we can see that these two brackets are the same, so that means we are going to factor out the common bracket, y minus 1, you remain with the 2y plus 3. So this is what we are obtaining after factorizing this expression in the numerator here. So we're going to write the two brackets that we have obtained. That is y minus 1 into 2y plus 3. So from this part, we can actually divide by y minus 1, which is in the denominator here. So by this, we can cancel y minus 1 and y minus 1 are common. So we can cancel the 2. So we are going to have our answer as 2y plus 3. But remember that we introduced y in place of 3 to the exponent of x. So our answer, we are supposed to replace, in place of y, we are supposed to substitute that 3 to the exponent of x that we had before. So our answer is going to be 2 by 3 to the exponent of x plus 3. So this is going to be the resultant from this expression if we are to simplify it properly. So these are the stages that you can have, or if you want, you can actually factorize this expression as it is without introducing y. Still, you're going to obtain the same answer, even though you need to be very, very careful in your calculations, but you can have the same answer from there. Let's check 1.32, which is the other part that we had on question number 1. In this case, we are given to simplify. So the first thing that we can have is to factorize the given expressions. That's the easiest way that we can have. So that's 1.32. We can even factorize this part here. 1.32. So let's start with the first part. We are given x squared plus x minus 2. So in this case, as we can see, we can factorize this direct. Since the coefficient of x squared is 1, we are going to focus with -2 here. What are the factors of -2? If we add them, we must get a +1. So we've got 2 and -1. If we multiply this, we get -2. If we add, that's a 1. So which means we are going to have two brackets, x plus 2, x minus 1. Okay, everything over from 6 minus 3x. If we are to cross-check here, 3 is common. But if we want to write this in terms of x, since we have seen that the other part of the expression, we are starting with x, we can factor out -3 so that this can be a positive. If we factor out from -3x, if we factor out -3, we are going to remain with x. 6 divided by -3, that's -2. So we can even write this expression this way. That's -3 into x minus 2. At least our expression is starting with x being a positive. Okay, we move on to the other part of the expression. We are dividing. Yes, we can introduce your multiplication from this part. Since we know that once we are dividing, we're supposed to introduce multiplication, then we invert the second fraction. So this x squared minus 3x plus 2 is now on the top, which is now in the numerator there. So you're supposed to factorize it in the numerator. So having the coefficient of x squared, which is 1, we just need two brackets that we are going to have in this case. So from the two brackets, we've got x and x. What are the factors of 2? But these factors of 2, if we add them, we must obtain the middle term, which is -3. So we've got -2 and -1. If we multiply these two numbers, that's +2. If we add, that's -3. So these are the two numbers that we are going to have, -2 and -1. All right, we move on to the other part, which is, since we have inverted, this x plus 2 is going to be written now in the denominator. So we shall have x plus 2 in the denominator. So that's x plus 2 multiplied by, already here we are multiplying, it's already multiplication, so there's nothing that you're going to do here. You're not going to invert anything, just you have to rewrite as it is. So it's 9 over x squared minus 2x plus 1. We're supposed to factorize again. Coefficient of x squared is 1. Let's focus with 1. What are the factors of 1 that we have? But these factors of 1, if we are to add them, we are supposed to obtain the middle term, which is -2. So we've got -1 and -1. If we multiply these two, that's 1. If we add, that's -2. So we're going to have x minus 1, x minus 1. So this is the stage that we are now from that first part that we're given. We've managed to factorize and also to introduce multiplication where it was necessary. So now we can cancel. As long the relationship is between the numerator and the denominator, we can be able to cancel the expressions like we've got x minus 2 here, x minus 2 here. we've got x plus 2 here, we've got x plus 2, we've got x minus 1 here, we've got x minus 1, we've got x minus 1 here, we've got x minus 1. We are left with 9 and -3. So -3 into 9, that is going to give us -3, or you can even use your calculator. 9 divide by -3, you're going to obtain -3. So that is what you're going to have on your final answer, which is a -3. So that was the simplification part. That is what you actually needed for you to obtain 6 marks from this part. As you can see it at 6 marks, which means the total on question number 1 giving us 14 marks. Okay, question 2, you're now given to solve for x the following equation. So this, the first part, we are given a log. Whenever you're working with logarithms, try by all means to apply the laws of logarithms. So this one is actually 6 marks, the first part, where we are given the logarithm of x, 1 minus x minus log of x plus 1 is equal to 0. So that's the first thing. We are dealing with a log where we know that if the base is not given, you are in base of 10. So this simply means you are in base of 10. So we know that if we are dividing, if we are subtracting, actually, we are going to divide the numbers. We are subtracting the logarithms. Then from our laws of logarithms, we've got something like this here. Let me write it. The logarithm of A minus the logarithm of B is the same thing as the logarithm of A over B. So if we are subtracting logarithm, provided that the bases are the same, you're going to divide the numbers. So that's what you're going to do here. This is your A and that's your B. So which means you're going to have the logarithm of the square root of 1 minus x over x plus 1. So this is what we have in base of 10. So this is a single logarithm and we equate to 0. So from there, we can convert, since it's difficult for you to simplify or to work out with logarithms, convert to index form or to exponential form, which is the easiest way to use, since we know that the logarithm of A in base of B, if it is equal to C, therefore it follows that A is equal to B to the exponent of C. So in this case, this is our A, this whole part here, this is your B, and this is your C. So you can actually have A, which is the whole square root of 1 minus x over x plus 1. That's our A, which is equal to B to the exponent of C. Our B is the base, which is 10. So it's 10 to the exponent of a 0, of which we know that 10 to the exponent of 0, that's a 1. Any number when raised to the exponent of 0 gives us a 1. So this is going to be 1. So we're going to remain with the square root of 1 minus x over x plus 1, which is equal to 1. And the 1 is same as 1 over 1 as a fraction. So you can cross multiply to remove the fractions. So you're going to have the square root of 1 minus x, which is equal to x plus 1. All right, now we are back to a normal equation. We no longer have any logarithm or any base that we have. Is now a normal equation. How do you remove the square? The square, you have to, the square root, you have to square both sides. So the moment you square both sides, you're going to have 1 minus x, which is equal to x plus 1 squared, of which if we expand this, we're going to have x squared plus 2x plus 1, which is a normal equation that we are used to. So how are we going to solve from this part? This is now a quadratic equation that we are having. So we can choose to rearrange this part so that we can have x squared plus 2x. If we transpose the minus x to this side, is going to be plus x. So it's 2x plus x, which is going to be plus 3x. We transpose 1 to this side of the equation is going to be minus 1. So 1 minus 1, that's a 0. So this is going to be a 0. We do not have anything there. All right, so that's what we have. X squared plus 3x is equal to 0. How do we solve this? We can factorize. X is common. If we factor out x, x squared divided by x, that's x. 3x divided by x, that is going to be 3, equal to 0. So from the 0 concept, we know that either one of these two should be equal to 0. So it's either that x is equal to 0 or x plus 3 is equal to 0. So from this part, x is going to be 0 or x is going to be -3. 3 to the other side of the equation is going to be a -3. So these are the answers that we are obtaining, x which is 0 or x which is -3. But if we are to consider our x now back to this expression, remember these are logarithms. So let's just try and substitute something here. If we are to put a -3, I want you to see what is happening, especially on this log here. We have got x plus 1. That's -3 plus 1. -3 plus 1 is -2, and we do not have log -2. Remember, a logarithm can never be a negative like this log -2. This cannot be simplified. So as you can see, x cannot be equal to -3. So therefore, our x is going to be equal to 0. That's the answer that you're going to have. So you can even test your answers after solving, substitute your values and see if they actually make sense from the given question that you have. Okay, let's see 2.12. Again, we are asked to solve for x. This time we're given the square roots and so forth. So it's the same concept as just a normal equation that you are used to. So in this case, what can we have? We can expand by removing the fractions first. Remember, if you are given a fraction, you can actually multiply each because this is same as over 1. This is same as over 1. So to remove this square root that we see, we can actually multiply by square root of x here, by square root of x here, by square root of each and every term. So by multiplying by square root of x, these two will cancel, which means you are going to remain with 5 minus, here we are going to have square root of x times square root of x. Let's get back to our laws of sets. We know that square root of a times square root of a is equal to a. So it's the same thing, square root of x times square root of x, we are going to obtain x. On the other part, we've got the square root of x plus 2 times square root of x. From our laws, we know that if we are multiplying two terms which are different, but under the square root, you combine those terms under the square root together. So square root of a times square root of b gives us square root of ab. So that means this x and the x plus 2 is going to be multiplied together. So we're going to have equal to the square root of x being multiplied to x plus 2. So this is going to be multiplied together. So we are back to the same format that we had last time where we had to remove the square root. So as we saw that to remove the square root, you're supposed to square both sides. We're supposed to square here, we square this side. So that's it. We are going to have 5 minus x squared equal to, by squaring, we are removing the square root. So we're going to remain with x into x plus 2. So that means we have to expand the brackets. So as you can see, by expanding brackets, you can choose to have two brackets which are the same, or you can use your identities. As you know, this is going to be 5 squared, which is 25, minus 5 times 1x, which is minus 5 times 2, that's minus 10x, minus 1 squared is going to be positive x squared, which is equal to x times x, that's x squared, x times 2, which is going to be plus 2x. So from this part, we are done. We can actually collect terms together, but by just checking here, we've got x squared and x squared. If you take either the other side of the equation, these two cancel, so which means this part is no longer there. So we are going to remain with 25 equal to transpose 10x or minus 10x to the other side of the equation. This is going to be plus 10x. So that means we are going to have 2 plus 10x, which is going to be 12x. So to find x, it's now a linear equation since x squared is no longer there. So you can divide by 12 both sides. You can divide by 12 both sides. So that means we can have our x as 25 over 12, or you can write in any other way that is necessary, but that is what you're going to have as the value of x. So these are some of the typical questions, how they can ask these questions. So you're supposed to be very, very careful how you also attempt these questions. Let's check question 2.2. There we are asked to simplify. This is not about solving, but it's for you to simplify the expression that you're given. So whenever you're dealing with an expression, it depends how you are going to rewrite your terms. In this case, we've got 2 by 9 to the exponent of x plus 6 by 3 to the exponent of 2x minus 1. So you can choose to rearrange and write in the way that you understand, especially in terms of the bases and exponents. In this case, we can target a base of 3. We have got 9, we've got 81, they can be written in terms of 3. 9 is same as 3 to the exponent of 2, but we've got x, so it's going to be 3 to the exponent of 2x. So that means this part can be written as, so this is 2.2, so you can even write this part as 2 by 3 to the exponent of 2x. We move on here, we've got 6 times 3. Already this is a base of 3, but if you have to cross-check, we are subtracting. That is 3 to the exponent of 2x minus 1. So we can separate this expression as that will be plus 6 by 3 to the exponent of 2x by 3 to the exponent of -1. So it depends, or you can just write it as 3 to the exponent of 2x over 3. It's just one and the same thing. All right, everything here over 4 by, we've got 81. In terms of 3, 81 is that's 3 to the exponent of 4. You can even try from our calculator, 3 to the exponent of 4. This is 81. So that means we can write it as 3 to the exponent of 4x. So that's what we have, and everything is being raised to 1 over 2x. That's an exponent, that one. So before we talk about, or before we refer to this exponent that is outside, let's simplify first this part that is inside the expressions that we have. Okay, from the numerator, which is the top part that we have here, we've got 3 to the exponent, in fact 2, which is common here. We've got 2 here from 2 and 6. 2 is common. Also 3 to the exponent of 2x is common. So you can factor out that. So that means we can factor out 2 by 3 to the exponent of 2x. What do we remain with if we factor out this? Here we're going to remain with 1 plus, if you factor out from this 6 here, if we factor out 2, we are going to remain with 3. So this is going to be 3 by 3 to the exponent of -1, everything over. So because this part you can't factorize, so you just have to write it as 4 by 3 to the exponent of 4x, and everything to the exponent of 1 over 2x. So some of these we can be able to simplify them. Let's simplify what we can. 2 into 2, that's 1. 2 into 4, that's 2 here. As you can see, I've got 3 to the exponent of 2x, 3 to the exponent of 4x. So we can divide this one. Here we can remain with the 3 to the exponent of 2x because we have got 4 of them. We divided by 2, so it's going to be 3 to the exponent of 2x. Also, we can simplify this part that is inside the bracket. That's even, we can use our calculator. 1 plus 3 by 3 to the exponent of -1. That's, we can obtain something like 2 there. So that's a 2. So which means from this part on the top, we can obtain a 2. All right, so we simplify this, we put 2, and these 2 can actually cancel because here we've got 2 that we have. So these 2 and these 2 can cancel. So which means on the top, we are just remaining with 1. So that's 1 over. In the denominator, we are remaining with 3 to the exponent of 2x. Everything to the exponent of 1 over 2x. So that's what you're going to have at the end. So from this part, remember how you're going to apply the exponent. This exponent is supposed to affect everything. It's supposed to affect 1 and also affect 3 to the exponent of 2x. But knowing that if you raise 1 to the exponent of any number, it's either to the exponent of 5 to the exponent of 10, that one is not going to change. So 1 is going to remain as it is. So we are going to have 1 over, but here we are going to have something like 3 to the exponent of 2x to the exponent of 1 over 2x, like that. So as you can see, 2x and 1 over 2x will cancel. This will cancel just like this, guys. 2x times 1 over 2x. So this can cancel. We've got 1. So it is going to be 3 to the exponent of 1, of which you know that 3 to the exponent of 1 is same as 3. So our answer was going to be 1 over 3. So that was the simplification part, and actually you can obtain 5 marks by doing that. So these are typical questions that you can be given. Let's see question 3, which is normal on word problems and also change of subject. So the first part, We are given 3.1, that's a word problem. There is a mother who is 3 times as old as a daughter. In 12 years, she will be twice as old as her daughter. How old is the mother? So this is the given condition that we are given. So since we have got 2 conditions that we have here, we are going to refer to the first one. This is 3.1. Here we are given the age of the mother in terms of her daughter's age. So let's refer now, what is the condition? Your daughter, we do not know her age, so we can just say let X be equal to the daughter's age. So here we are referring to the daughter's age. All right. Since we now have the daughter's age in terms of X, now we can refer to her mother in terms of what? In terms of X, because we are given that a mother is 3 times as old. So which means the mother is going to be 3 times, which is 3X. So 3X will be equal to the mother's age for that moment that we are given. All right, so this is a situation that is happening currently, like for now. Then after some time, we are now given that in 12 years time. So now we are referring to a condition after 12 years. So let's see what we have after 12 years. After 12 years, since the daughter currently, she was having X years. So after 12 years, it is going to be X plus, because it's just in 12 years time, after 12 years, so you add. So we are going to have X plus 12 as the daughter's age. So this is going to be the daughter's age. All right, but we are not given a condition that we have for the, but we are given that the mother there, she will be twice as old as the daughter in 12 years time. Okay, this is what we have for the daughter. The daughter is actually X plus 2. And the mother is said to be twice. So which means we are going to multiply twice, which means by 2. So which means the mother is going to be X. This is 12. So the mother is going to be 2 times X plus 12. That is twice. So this is going to be the mother's age after 12 years. From the given expression that we have, we can actually understand that this part that we have, let us consider the conditions that we have from the mother and also from the given daughter that we are given in this condition. Let's say if we are to take from the normal consideration, because we want to formulate the equations now. If we are given that in 12 years time, the mother is going to be twice as old as the daughter, which means we are actually referring to the equation that we are formulating an equation to say, if we are to multiply the daughter's age, it is going to give us the mother's age. All right, let's take a condition whereby we are having the mother's age, which is 3x as the age, this one, the 3x as the age. In 12 years time, we want to know in terms of that age, what was the mother's age in 12 years to come in terms of 3x, because that's your age currently, which is 3x. So referring to her actual age that she's supposed to have, it is supposed to be 3x plus 12. That's the mother's age, not referring to her daughter's age in 12 years time. All right. So these two here, they are equal in 12 years time. So we can formulate an equation from these two, because we are referring to the mother's age in 12 years time as twice the daughter. We are also referring to the mother's age in terms of her original age that she had. We just added a 12. So now we have got two equations which are equal, but they are just written in different formats or in different ways. So having these two expressions, that means we can actually solve for x, because these two, they are equal. So you can formulate an equation to say 2 into x plus 12 is equivalent to 3x plus 12. So that's an equation that you can solve. Expand brackets, we've got 2x plus 2 times 12, which is 24, is equal to 3x plus 12. So you can transpose, that will be 24 minus 12. If we transpose 12 to the other side of the equation, to the left-hand side, is going to be negative 12 is equal to, we remain with 3x on the right-hand side, transpose 2x to this side, we are going to obtain negative 2x. So that's what we have. 24 minus 12, that's 12, is equal to 3x minus x, which is x. So x is referring to the original age of the daughter here, because we are given that the daughter's age is x years. Now we are given how old is the mother. Take note, we are referring to the condition, to the now condition, not to the after 12 years. Now, currently, the age of this mother is 3x. So, which means the mother's age is going to be 3 times x, of which we've got our x, which is 12. So 3 times 12, that's 36 years. So currently, the mother is 36 years old. The daughter is 12 years old. Then after 12 years, it's another condition. We are worried about the current situation. That is what we have in this case, to say the mother is having 36 years of age. So that is what we are going to have. There are so many ways that you can work out word problems. These are word problems, guys. There are so many ways that you can simplify or solve them. Okay, 3.2, we are given a condition whereby we are asked to make D the subject of the formula. We are given an equation. And take note, there are two D's here, the capital letter D, small letter d. So we want to have the small letter d as the subject of the formula. So what's the first thing? We can actually cross multiply to remove the fractions. So this is going to be a into d plus dk, which is equal to 1 times db, which is db. So that's it. We can expand brackets by a times d, that's ad, plus a times dk, that's adk, which is equivalent to db. So since we can see that we have got d on this side, we've got another d on the other side of the equation, so we can transpose the adk to the right-hand side. So we're going to have db. If we transpose plus dk across the equal sign, it is going to change its sign. So it is going to be minus adk. D is common, so factor out D from this part. If you are to factor out D, you remain with the B minus AK. So to find D, just divide by the bracket both sides. So if you divide by the bracket both sides, you have got the D as the subject. So let's cancel both sides. So therefore, our D can be written as AD over B minus AK. So that is what we have as the subject. So there are so many ways also of rewriting or having expressions as change of subject. You can choose any way, as long you are following the proper stages. There are so many ways and of rewriting or writing these answers that we have. Let's check the other part of the question, which is question number 4. On question number 4, we are given 2 straight lines AB. That is the line AB and the line AC. They intersect at A, which is the y-intercept also for both graphs. As you can see, it's the y-intercept for both graphs. From these, we are given the angle of inclination of AB is theta, and the angle of inclination of AC is beta. Given the points A, which is 2, 0, 2, this point A is 0, 2, so we are given the coordinates of A, that's 0, 2. The coordinates of B here, we are given the coordinates of B, which is minus 2 over 3, 0. The coordinate of C, which is 3, 0. So we have the coordinates of the given lines. Determine from this information, let's see what you're asked to determine. The first part, the gradients of the line segment AB and AC. So we need to find the gradient of AB and the gradient of AC. So as we know that gradient is the change in Y over the change in X. So this is 4.1. We have got the gradient of AB. So let's start with AB. So the change in Y over the change in X. All right, so we can name our points AB. We can just name this is X1, Y1, this is X2, Y2. So let's substitute the values. Y2 that's a 0 here, minus y1, which is 2, over x2, which is minus 2 over 3, minus x1, that's a 0. So that's what we have. So you can divide this from your calculator direct. That's 0 minus 2 over minus 2 over 3. So this is minus 2 over 3 minus 0, of which there's nothing that we are subtracting. So it just remains as it is. That's a 3. All right, so the gradient of line AB is going to be 3. This is what we are obtaining from the gradient of line AB. That is 3. Then we move on to the other part, which is AC. So we also need to find the gradient of line AC. So having our AC, you can just even write it here, the gradient. So we've got the gradient of line AC. So this time on AC, we've got x1, y1. So you can even name this x2, y2. So using the formula I've already written y2 minus y1. So that's 0 minus 2. So you're going to have 0 minus 2 over x2 minus x1. That's 3 minus 0. So that's 3 minus 0 here. So you're going to have negative 2 over 3. So this is the gradient of line AC. All right, let's see the other part of the question, that is the distance between B and C on 4.2. So 4.2, we need the distance between B and C. This is where we are having our B and C. So we've got a 4.2 here from B to C. So yes, we can use distance formula, but this one we can just subtract. From B to C is 3 because it's a horizontal line. So this one is direct 3 minus 2 over 3. That's the distance. You just have to add. So 3 minus 3 over 2, that's BC, which is 3 2/3, if I'm not mistaken here, units. All right, so that's 3 2/3, or you can use your distance formula. Since you've got points, remember the distance formula, it states that the distance from A to B can be written using the formula, that's x2 minus x1 squared plus y2 minus y1 squared. So in this case, we can subtract AB being the square root of x2. That's 3 minus a third. So we've got 3 minus a third, which is 3 plus a third. So it's 2/3, sorry, that's 2 over 3 squared plus y2 minus y1, that's 0 minus 0 squared. So we've got 0 minus 0 squared. So you can use this from your calculator. Still, we are going to obtain the same answer, which is going to be 11 over 3. So from your calculator, you're going to obtain 11 over 3 units. That's the same as 3 2/3. So for the length or the distance from B to C. Okay, let's see the other part, which is 4.3. On 4.3, we need to find the equation of line AB in the format y is equal to mx plus c. Remember, previously we got the gradient of AB. So to find the equation is easier because we have the gradient already from this one. So from line AB, you're going to take any point that you have that is, this is our line AB, and the gradient of AB, we got 3. All right, so that is, we are going to have, this is 4.3. So already we've got a gradient of 3. The gradient of AB is equal to 3. So it was going to be an advantage on AB since we have already the y-intercept. Remember, the format that we are given to write in the format of y is equal to mx plus c. Remember that c indicates or represents the y-intercept. So therefore, your equation is going to be y is equal to m, which is the gradient, plus c. Our c is the y-intercept, which is 2. So that was the equation. Yes, you can substitute a point of your choice, or you can use the equation y minus y1 is equal to m into x minus x1. Still, you can obtain the same format or the same equation that we have on 4.3. So let's check the other part. 4.4, we are now asked to find or to determine the equation of the line which is going to pass through the point A and is parallel to the x-axis. So if it is parallel to the x-axis, it means we are just taking the equation at A as it is. Remember, parallel, we are having a line like this. This is at point A. It's parallel to the x-axis, so it's a straight line. And we know that all these lines at I is going to be y is equal to the point where it passes through A, it passes at 2. So that one, it is going to be y is equal to 2. So this one was a direct one. As you can see, it's also 1 mark here. So y is equal to 2. 4.5, the equation of the line passing through B in the form of y is equal to mx plus c, which is perpendicular to AB, show all steps. So this time we've got the equation, this one is going to pass through B. So point B, remember point B is minus 2 over 3. So let's just write this aside. This is 4.5. So the point B, we've got our point B, that's negative 2 over 3, 0. And we are told that this line is perpendicular to line AB. Let's check again our question. The equation of the line passing through point B in the form of y is equal to mx plus c, which is perpendicular to AB. So remember, for two lines to be perpendicular, the product of their gradient should give us negative 1. So that means the gradient that we need times the gradient of line AB should give us a negative 1. So we have the gradient of AB, which is 3. So we must get negative 1. So divide by 3 both sides, which means we've got a gradient by 3 both sides. So M is going to be negative 1 over 3, which is the gradient. So remember, you're finding the equation in the form of y is equal to mx plus c. So there are so many ways you can just substitute direct into the equation, into the format of the equation that you're given, which is y is equal to mx plus c. Since m is there, so y is equal to m, that's our gradient. In place of m, substitute minus 1 over 3x plus c. So to find c, we are going to substitute the point x and y. This is your x, this is your y. Y is equal to 0 when x is equivalent to, okay, let me just change here. When x is, y is equal to 0 when x is equal to minus a third. So that's minus a third times x, which is minus 2 over 3 plus c. So that means we can find the value of c from this one. If you multiply, that's 0 is equal to minus a third times 2/3. We can multiply direct. This is going to be positive 2 over 3 times 3, that is 9 plus c. So transpose is going to be negative 2 over 9, which is equal to c. So therefore, the equation of c is going to be y is equal to mx. Remember, we've got minus a third x plus c. Our c is negative 2 over 9. So this is the equation that we are going to have at the end. So there are so many ways, methods that you can apply to find the equation. As long as you are doing the proper way, that is what is important. Okay, 4.6, the size of the obtuse angle beta, that is the angle beta, the angle of inclination of line AC. So let's check our line AC. This is where we have our AC beta. This is your beta here, which is the obtuse angle, the one that is indicated here, the obtuse angle. So remember, if you have an obtuse angle, you are going to find the angle in the other angle, which is alpha, not the angle of inclination, but the other part of the angle. Then from there, we can find beta, which is the obtuse angle. So let's see, this is our 4.6. Let's just work it aside. We calculated the gradient of AC before. We have the gradient of AC. Yes, we calculated the gradient of AC here. We got negative 2 over 3. So from this gradient, we are going to calculate the angle, which is alpha. Then we can have the angle beta. All right, so let's see what we can have here. From the gradient, we know that tan of theta is going to be the gradient. Then the alpha that we have is going to be arctan the gradient. So it's arctan the gradient, which we said is negative 2 over 3. So our alpha, that's arctan, the gradient that we have. So let's see what we have. Shift tan, negative 2 over 3. So this is going to be the reference angle, not the beta, but the alpha, which is negative 33.69. So you can just write this as negative 33.69 degrees. So to find the actual angle now, which is beta, let's put this on the diagram, 33.69. So this is where we have 33.69. going to indicate here. So this is where we have 33.69 degrees. So to find this angle beta here, we are going to subtract from 180, since we know that angles on a straight line add up to 180. So therefore, our beta is going to be 180 minus that one. So beta is 180 minus 33.69 degrees, which is our beta is going to be, from our calculator, let's see, 180 degrees minus 33.69, that's 146.31 degrees. So we've got 146.31 degrees. Okay, so that's our beta. We move on to the other part, which is 4.7. The size of the acute angle BAC where lines AB and AC intersect with each other, and that is 4 marks for that. Okay, so BAC, let's see from our diagram where we have our BAC. So this is where we've got B, A to C, which means we are referring to this angle here. That's our BAC. All right, to find the BAC, it is going to be easier for us to find this angle if we have the angle theta, this angle theta, the angle of inclination of line AB. So that means you can calculate angle theta first from this part. Angle theta, since we have got the gradient of line AB, sorry, here we've got the gradient of line AB, which is 3. So we're going to find angle theta from that gradient, since it is the angle of inclination. So we can have this 4.7. So you can find theta first, which is arctan, the angle of inclination, which is arctan, the gradient 3. So from our calculator, arctan 3, that's shift tan 3 is going to give us 71.565, which is something like 71.565, 71.7, that's 565 degrees. We have got 565 degrees as our theta. All right, so I'm going to indicate on the diagram where we've got our 71.565 here so that we can understand each other. So this is where we are going to have our 71.565 degrees. Now you want to calculate BAC, knowing that angles in a triangle, they add up to 180 degrees. So you're going to subtract these two angles, angle B and angle C, from 180 degrees. We now have BAC. So therefore, our BAC here is going to be, angle BAC is going to be 180 degrees minus the two angles that we have, which is 71.565. So this is 65 degrees plus the other angle that we got, that other part, which was 33.69. So we add also 33.69 degrees. Okay, so by subtracting these two angles from 180 degrees, we are going to find the acute angle BAC. So it's minus 71.565 plus 33.69 degrees, which is going to be 74.745. So this is angle BAC. So therefore BAC is going to be 74.745 degrees. That's our angle BAC. So that is what we actually needed to have the acute angle BAC. That's a sum of 19 marks in this question 4. So these are typical questions, guys, that you can actually have, and it's very, very important for you to understand the basic concept of angles, the Cartesian plane, the gradient, the equation of a straight line, and the relationship between parallel lines, perpendicular lines. That's what is very, very important in this type of a question. Okay, question 5, we are given fig B shows the function f of x, which is equivalent to negative x squared, negative 3x, and gx, which is equivalent to 4 minus x. So gx is a straight line, and the other one is a quadratic graph. So this is gx, which is y is equal to 4 minus x. And from this, f of x is y is equal to minus x squared minus 3x plus 4. That's what you're given. And these two graphs, they intersect at D and E, as we can see from that part. Okay, so first part was to calculate or to find the coordinates of B and C from question 5.11 by using the technique of completing the square. So the coordinates of B and C. What does B and C indicate? B and C here, these are the solutions of the graph, as we know that we are in the x-axis, where we know that in the x-axis, y is equal to 0. So if y is equal to 0, what are we going to have? That is the question. Okay, so let's see. B and C, we are going to use the completing of the square method. Okay, so I'm just going to have a question here. That's 5.11. So that's from our f of x. We had our f of x being equal to minus x squared minus 3x plus 4. And to find the x-intercepts, we are saying y is supposed to be equal to 0. So this part is supposed to be equal to 0. But you're told the method to use, not factorization, not quadratic formula, but completing the square method. Okay, we know that when using completing the square method, the coefficient of x squared must be a 1. So you're supposed to divide by negative. That's x squared plus 3x minus 4 is equal to 0. Here we are dividing each by negative 1, by negative 1, by negative 1, by negative 1, each and every term. So we can transpose the constant part to the other side of the equation. That's negative 4 is going to be positive 4. So remember, whenever you're working with completing the square, you're supposed to find half the coefficient of x, which in this case, the coefficient of x is 3. So half the coefficient of 3, that's a 3 over 2. Then we square the half. So you can write the equivalent or just leave it like that, but you're supposed to add this square both sides of the equation. So it's going to be x squared plus 3x plus the square, which is 3 over 2 squared, that is 4, plus 3 over 2 squared. Okay, so from the left-hand side, we are supposed to factorize, but to factorize, we just take the first term, which is x, and the last term, so you take this part, which is having a square, that is the x here, and that half, which is 3 over 2. So this is going to give us x plus 3 over 2 squared, which is equal to, this other part you can simplify from your calculator. 4 plus 3 over 2 squared. This one we can just simplify and see what you have. That's 11 over 2. So this is 3 over 2 squared, like that. Okay, so it's going to be 25 over 4. So you're going to obtain 25 over 4. So how do I remove the square of 2? Going to introduce the square root both sides, introduce the square root both sides. So that's x plus 3 over 2 is equivalent to plus or minus the square root of. Remember, whenever you're dealing with square root, it's a plus or minus. So it is going to be plus or minus. Square root of 25 over 4 can be simplified from your calculator. The square root of answer, that's 5 over 2. So it is going to be plus or minus 5 over 2. So to find x, going to transpose the minus through the plus 3 over 2 to the other part of the equation. That will be negative 3 over 2. So x is equivalent to negative 3 over 2 plus or minus 5 over 2. So let's separate minus 3 over 2. Going to start with a plus here. So it is going to be plus 5 over 2. Or x is equivalent to minus 3 over 2. This time we are going to work with the minus. So it is going to be minus 5 over 2. So that's it. You can use your calculator to simplify this part here. Negative 3 over 2 plus 5 over 2. That's plus 5 over 2, which is going to be a 1. So x is giving us a 1, or x is going to give us, let's see the other part. That's negative. This time we just remove the plus and put a negative. So that's minus 4. So x is going to be minus 4. So take note of the question. Let's get back to the question. Let's answer the question here. The question is for us to find the coordinates of B and C. So you're supposed to answer now comparing the values. This is where we have got our 0 here. So which means C is positive and B is negative. So B is going to be the negative 1, which is B is going to be negative 4. In this case, we've got a negative here. So B is negative 4. Remember, we said y is equal to 0. So that's minus 4, 0. And C is going to be the positive, which is 1, 0. So you're supposed to compare the points now from the answers that you got and with the graph that you have. So now we've got the point C and the point B. So this is -4 and this is 1. That is what we have from this part. Okay, let's see the other part, 5.12. We are given to find the coordinates of A, the turning point of F. So to find the turning point, there are so many ways that we can use to have the turning point. You can use the derivative. You can also use x is equivalent to minus b over 8, because what we need is the turning point of A there. So let's see, that's 5.12. Just going to have it here. Okay, 5.12. Knowing that at any turning point, x is equivalent to minus b over 2a, which is from this question, this is your A, your B, your C. So minus B, that's -3 over 2A, which is 2 times -1. Remember, our A, this is same as -1. Okay, so we can simplify to find the value of A. That's negative. Okay, we can just have our fraction first here. We can have negative in bracket -3 over 2 by -1. So this is 2 by -1. Your calculator is good at simplifying all these values. So you're going to obtain -3 over 2. So this is the value of x at the turning point, which is -3 over 2, which is, you can find this by the derivative. We know that f prime x should be equal to 0 at any turning point. So you can even use this and you obtain the same answer for x. To find the value of y, you have to substitute in place of x. We are supposed to substitute now the value of x that we obtained, which is 3 over 2. So y is going to be minus x, which is -3 over 2 squared, -3 times -3 over 2 plus 4. So by doing this, we are going to obtain the value of y, which is going to be, okay, let's see from our calculator here, that's negative bracket, -3 over 2 squared. So we've got -3 over 2 squared, -3 into bracket -3 over 2. Whatever that we have here, we add 4. So if we add 4, we are going to obtain 25 over 4. So that is what we have. So therefore, A, which is the turning point now, this here, our A is now a point. A point, remember, is made of A, X, and Y. So our X is -3 over 2. Y is 25 over 4. So that is what we are having at the turning point. So these are the typical questions that we can actually have, or that we can. So like I said, we can use this concept. You can use the derivatives. Still, you can have the same answer as like this one. 5.13, we are now given a condition to find the coordinates of D and E, the point of intersection of F and G. Okay, this is what is happening between F and G. We have got truly, we have got D and E here. This is the point of intersection. So whenever you are dealing or you are working with the point of intersection, this is what you're supposed to take note about the point of intersection. So this is 5.13. I'm just going to work it here. At any point of intersection, the two graphs are equal. They will be equal at any point of intersection. So I'm saying at any point of intersection, it simply means the two graphs are equal. So therefore, f of x is equal to gx. So what does it mean? You're supposed to solve the given equations simultaneously. We have got the first equation of y is equal to minus x squared minus 3x plus 4. The other equation is y is equal to 4 minus x. And these two, they are equal at the point of intersection. So if they are equal, it simply means you have to equate the two equations. So I'm just going to equate minus x squared minus 3x plus 4 is equal to 4 minus x. That's what it means actually. So let's solve the equation. Collecting terms to one side of the equation, we are going to have negative x squared. If we transpose negative x to this side of the equation, it is going to be a plus x. So it's -3 plus 1, which is -2. So we're going to have -2x Here we've got 4 minus 4. If we transpose this to the other side of the equation, that will be a -4. So 4 minus 4, that's a 0. So you're going to obtain a 0 from that side. Okay, so from this part, let's solve. We can factor out x, which is common. We remain with minus x minus 2 is equal to 0. So from the 0 concept, it's either x is equal to 0 or minus x, or we are going to have minus x minus 2 is equal to 0. So solving this part, we can transpose minus x is equal to 2, divide by minus 1, both sides. So x is going to be minus 2. So x is equal to 0 or x is equivalent to -2. If we are to check properly, that's what we have. From these 2 points, this is where we have our y-axis. That's our y-axis. So which means from this side, E is the one where x is equal to 0 here. And D is the one which corresponds when x is equivalent to -2. But this is a point, so you're supposed to state now the coordinates. When x is -2, what is the value of y? When x is -2 here, what is the value of y? When x is equal to 0, what is the value of y? So where are we going to have these values? We just have to substitute into any of these two equations. Remember, we said at the point of intersection, these two equations are equal. So I'm just going to substitute on this simpler one. When x is equal to 0, y is equal to 4 minus 0, which is y is equal to 4. So it's a point that we have, which is 0, 4. Okay, we move on. When x is -2, we substitute -2 here. Y is going to be 4 minus x, which is -2. So minus and minus, that's a plus. So y is going to be 6. So that means it's now a point, which is -2, 6. Okay, so like I said here, which one is -2, 6? Which one is 0, 4? E is the one where x is equal to 0 because it's in the y-axis. So E is the one that carries a 0 here. So this is where we are going to have our E. So this will be your E, and D is the one that is going to carry -2, 6. So these are the 2 points that we're being asked to calculate or to find from the given graph. So that one we can use simultaneous equations to solve for that. Okay, let's see the other part, which is 5.2. We are given to determine dy dx of the function, that's a function of x, by using the rules of differentiation. The answer must be with positive exponents. Take note, we are given a condition. The answer is supposed to have positive exponents and in said form where applicable. So it's very, very important that we rearrange in a manner that we actually understand. So this was 3 over the cube root of x minus 3 square root. So actually this is supposed to be square root of x plus 2 pi. Okay, so that is what we have. Okay, so let me just have it aside here. I think it can be fine. So this is 5.2. We've got y is equal to, I'm going to rearrange first. Remember the cube root of, from our laws of exponents, means x to the exponent of a third. But we are having it in the denominator. So to write it in the top, it is going to be to the exponent of minus a third. Okay, we have got minus 3 square root of x, which is minus 3 square root of x means x to the exponent of a half plus 2 pi. So this is what we have. So let's find dy dx. Take note, this is a derivative of y with respect to x. So remember the concept, we drop the exponent, we multiply. So this is 3, so it's going to be 3 times. If we drop this exponent, which is minus a third, we are going to multiply by 8, which is minus a third x. Then we subtract 1 on the exponent. So it's minus a third minus 1. So from your calculator, minus a third minus 1 is going to give us something like -4 over 3. So this is -4 over 3. All right, -4 over 3, sorry. -4 over 3. Then we move on to -3, do the same. -3 times, we drop the exponent, so it's going to be 1 over 2 x. We subtract 1, just like what we did. So it's a half minus 1. That one is a minus half. Okay, then we've got 2 pi. Remember, we do not have x, so the derivative of a constant is equal to 0. So there is nothing that we're going to write there. All right, so from this part, let's simplify. Dy dx is going to give us what? 3 times minus a third, that's minus 1. We can use a calculator. 3 times minus a third, that's minus 1 over 3, is going to be negative 1. So we are going to have negative x to the exponent of negative 4 over 3. Then here we've got negative 3 over 2x to the exponent of negative half. Remember what we had before? We had to rewrite this in terms of positive exponents. So we are going to rewrite again back to the same way that we had before. This is x to the exponent of a negative, which is 1 over, to remove the negative exponent, it's going to be 1 over x to the exponent of 4 over 3. We do the same here, minus 3 over 2x to the exponent of a half. But remember, we are told to live in terms of positive exponent and also in said form. Wherever it's applicable, leave your answer in said form. So in said form, that means your answer is supposed to be under the square root, of which is very, very proper here, because we know that x to the exponent of a over b is the bth root of x to the exponent of a. So that means here we can rewrite our dy dx as minus 1 over x to the exponent of 4 over 3. That will be the cube root of x to the exponent of 4 minus 3 over 2. Remember, x to the exponent of half, this one, guys, we must know this one is square root of x. We also talked about this before. So that is your final answer in terms of positive and in terms of sets, wherever it was applicable to do that. Okay, so that's it, 5.3. 5.4, 5.3, sorry, we are 5.3, determine the gradient of the tangent. So there we are asked to determine the gradient of the tangent of the curve at this point. Okay, so whenever you are finding the gradient, we know that gradient is simply dy dx at that given point. That is how you find the gradient expression. So this is 5.3. The gradient of the tangent to this curve at a point where x is negative 1. So gradient is simply the first derivative. So it's going to be the first derivative of x where x is equal to minus 1. That is how we are going to have it. So that means we have to find the first derivative first. From this, our first derivative, that is, we are differentiating 2 and 3 is going to be 6x squared, minus 3 and 2 is going to be 6x. You've got plus 1x, which is plus 1, minus 1, that's a constant. So this is your first derivative. When x is equal to minus 1, that's your gradient now. So gradient, you simply find the derivative, then you substitute the value of x. So it's 6 into minus 1 squared, 6 into minus 1 plus 1. So this is your gradient. So the gradient of that tangent is going to be what at the end? So it's 6 by negative 1 squared, 6 by negative 1 squared, minus 6 by negative 1 plus 1. So this is what you're going to have, which is 13. So the gradient at that point where x is minus 1 is 13. Okay, the other part, we are asked to draw the graph of y is equal to 16 over 9. Okay, this is, we do not know, showing the point of intersection, so it's supposed to be minus x squared, something like that. Okay, I just hope this was it. So from this graph, we are supposed to show the point of intersection and so forth. Okay, so let's see what you're going to have. I'm just going to remove this part here. Okay, let's just remove this part. I'm just going to work it out on this part. That's 5.4. All right, 5.4, we have got y is equal to the square root of 16 over 9 minus x squared. So you can remove the square roots and so forth so that we actually understand what we have from this part. We can have it in a way that we understand. So let's start, or we can even leave it like that, guys. When x is equal to 0, let's start with the x-intercepts. X-intercepts, that's when y is equal to 0. Okay, so when y is equal to 0, we are going to square both sides to remove the square root, that's 0 is equal. If you square this, guys, it is just going to remain as it is 16 over 9 minus x squared. So let's find x to the other side of the equation. We are going to have x squared is equal to 16 over 9. Introduce the square root. So your x is going to be plus or minus. Remember, guys, square root of any number, that's a plus or minus. So x is going to be plus or minus the square root of 16 over 9. So let's see the square root of 16 over 9. That is 4 over 3. So we are going to have a plus or minus 4 over 3. Okay, to find the y-intercept, so for the y-intercept, we know that x will be equal to 0. So if x is equal to 0, you can substitute y is equal to the square root of 16 over 9, because this is 0, yes, it's going to be 16 over 9. So if we are given this format, is supposed to be working with a positive square root. In this case, it was supposed to be positive. So working with a positive, y is going to be plus 4 over 3. We are not having plus or minus, so it depends with format that you're given. If you are given as plus or minus, which means y is going to have two values. So this was actually an error type of equation. You're supposed to be told how to have this y in terms of, okay, so anyways, that's it. We can see that this is an ellipse. This is supposed a half circle actually, because y and x are the same. So it's not an ellipse, but it's a half circle. So we are going to have a half circle with x being 4 over 3. So you can even draw a circle from minus 4 over 3 to 4 over 3. So you can have our half circle like this. At x is equal to minus 4 over 3 to 4 over 3, and y at 4 over 3. So that's it. And don't forget to write the equation of the line. So y is equal to the square root of 16 over 9 minus x squared. So this one, it's a plus. If it was plus or minus, it was going to be a complete circle like that at minus 4 over 3. But in this case, we are just referring to a half circle. So that's what we had on question 5.4. In question 5.5, we are now asked to draw the graph of y squared is equal to the 4x, showing the coordinates of the turning point and the value of the point of intersection with the axis. So what type of a graph do we actually have? Remember, every graph is supposed to be written in terms of y. Okay, so let's have this down here. So that's 5.5. We are given the graph of y squared is equivalent to 4x. So for us to have this graph, we can actually introduce the square root. So which means y is equal to the square root of 4x. So from this one, we can have the values of y ranging from a plus or minus. So it is going to be just a quadratic, the same way that we have a quadratic graph, but in this manner. All right, so let's just have our Cartesian plane. That's our x here, that's our y. We've got at 0 here. So you're going to see that if x is equal to 0 here, we are going to have y being at 0. That's what we have at 0. It's going to remain at 0. Let's take at 1. If x is 1, y is going to be plus or minus 2, because you're going to have square root of 4, which is plus or minus 2. So the answers, they are going to be plus or minus, plus or minus. So at the end, we are going to have a format, a graph in this manner, because each value that is positive is also going to be seen in the negative region. So it is going to be a quadratic of this manner. That's what we have, y squared is equal to 4x. So you can just indicate the values like which corresponds direct, like the one that we had when x is 1. We know that this one is going to correspond here with 2, and here it is going to correspond with negative 2. So that's the same way that you're going to have, even if you move on to 0.4, and so on and so on. So there are so many ways that you can have. So the question was for you to indicate the values at the point of intersection with the axis. Do we have anywhere that the graph is indicating with the axis? We just have this point at 0, 0. That's what we only have from that part. So that was actually what we had on question 5, which is the last question on question 5 to have a total of 24 marks on question 5. Okay, let's see the other part. That's question number 6. 6.1, use trigonometric identities to prove. So this time you are working with identities. With sec minus 1 over 1 plus sec, which is equal to 1. This was 1 minus cos. This was 1 minus cos x over cos x plus 1. That was the identity that we are given. All right, so I'm just going to rewrite this part aside so that we can work it properly together. 6.1 sec, it was easier for us to actually choose, because we are choosing the side that you're going to work with, either the left-hand side or the right-hand side. I don't know which one, but as for me, I'm just going to choose left-hand side. All right, so sec, I'm just going to write sec minus 1 over 1 plus sec x. Remember, sec is 1 over cos. It's whenever we've got a sec, it's 1 over cos. Sec x is 1 over cos x. So in this case, we were supposed to rewrite. We can just actually rewrite this. So it's going to be 1 over cos x minus 1, everything over 1 plus cos x. That's 1 over cos x, sorry, 1 over cos x in this case, because we are referring to sec as 1 over cos of x. So what does it mean? We're supposed to actually add from this part here, because this is same as over 1. So you're supposed to add, finding the LCM of the 2 of cos x and 1, which is going to give you cos x. So this is the numerator. So remember, if you're adding, so adding or subtracting, one is the same thing. So it's cos x divided by cos x, which is 1. 1 times 1, that is 1, minus cos x divided by 1, that's cos x times 1, which is going to be cos x. So take note, this is the numerator that we have. We divide whatever that we have to the denominator. Since these two are the same, it's only that here we are adding. So we are going to have again cos x over, because this is same as over 1. So cos x and 1, that is cos x plus cos x and cos x, that's 1 times 1, which is 1. So this is what you're going to have. Remember, guys, that we are dividing this fraction here to the second fraction. So whenever you're dividing, you introduce multiplication and invert the second fraction. So it is going to be 1 minus cos of x over cos of x times. We have introduced multiplication, we invert the second fraction. So it is going to be cos x on top over cos x plus 1 in the denominator here. So cos x and cos x can cancel. That means we are going to have 1 and 1. So 1 minus cos x times 1, that's 1 minus cos of x over cos x plus 1 is going to remain as it is, which is cos x plus 1. All right, let's see if it is truly the same thing that we had, 1 minus cos x plus 1. So that's what we had on the right-hand side. This is exactly what we had. So it is the same thing as what we had on the right-hand side. So that's it, 6.1. 6.2, calculate the values of x for which x is going to range or in the interval from 0 to 360. So your x is from 0 to 360. If 3 cos of this is equivalent to 2,0007, okay, that's an equation that you're supposed to work from 0 to 360. So it's a play around type of equation, guys. Just play around with these equations. Okay, so the first thing for me, it was to divide by 3 by 3. I think it's going to be easy. So you're going to have cos x minus 40 degrees, which is equivalent to, from our calculator, if you divide 2.007 divide by 3, let's see, we're going to have 0.69669. Okay, so that's 0.669. Remember, I told our x is supposed to be from 0 degrees to 360 degrees. Okay. In order for you to have, we are going to find the reference angle. Forget about this x minus 40. We are just going to have our reference angle in this case, whereby we know that the reference angle is taken from arc cos of the decimal part that we have, which is 0.669. That is where we are going to have our reference angle. Make sure that your calculator is in radians. So it's shift cos 0.669, which is something like 48.010, like that, which is 48.01 degrees. We've got 48.01 degrees as the reference angle. But in this case, we are referring to a cos which is a positive. So from our quadrants, we know that we've got all students take calculus, all students take calculus. Where do we have the course being a positive? Because in this case, we are referring to a course which is a positive. We've got the first one in the first quadrant, course is positive, and also in the fourth quadrant, course is a positive. So in the first quadrant, we are going to take the angle as it is 48.01. We also have the 48.01 degrees here. So that means we're going to have two answers that we are going to have. 360 minus 48.01. Let's see, 360 minus 48.01 degrees. That's 319.99. So we've got another angle, 319.99 degrees. So now let's refer back to the x minus 40 that we ignored on the first part here. So we're going to say x minus 40 degrees is equal to 48.01. Remember, we said we've got two angles, or the other one, x minus 40 degrees, which is equal to 311.99 degrees. So from these two, what are we going to have as our x? First one, we are going to transpose minus 40 to add, that's 48.01 plus 40 degrees, or another x, which is equal to 311.99 plus 40 degrees. So we've got two values of x that we are going to have in this case, which is 88.01 degrees, or another x, which is going to be, if you use your calculator properly here, that's 311.99 plus 40 degrees, which is going to be 351.99. So it's 351.99 degrees. Okay, so that was the values. These are the values of x actually that we can have from 6.2. That is what the question was all about, to calculate the values of x from 0 to 360. As you can see, these values, they are in the interval from 0 to 360. They qualify in that interval. So that's it. We have got 6.3, which is to application of solving triangles on this question 6.3. All right, if we are given that the fig C that we see is actually represents a quadrilateral. So it's a quadrilateral, and AE, it's a perpendicular bisector. Perpendicular bisector meaning to say it's bisecting at 90 degrees. Remember, to bisect is to divide into two equal parts. So we've got 90 degrees divided into two equal parts. As you can see, we've got 28 meters, 28 meters from BE to EC, while E is the joint to D. So E that we see here is a joint to D, that's line ED. We are given the angle 61 degrees, which is ABE, being 61 degrees, AED, that's A to E to D, being 43 degrees, that is the angle here. We've got 43 degrees, then 90 degrees on this other part, and 56 degrees on EDC. EDC, that is 56 degrees. That is what we have. Determine the area of triangle AED. AED. This is what we have in actual sense, the triangle AED. So we are asked to determine the area of triangle AED. So which concept can we actually use to have this area? We can actually see that if we had this part, okay, let's check the number of marks, because what we have here is going to take a lot of marks. Okay, it actually deserves these marks, which is 8, because here we are supposed, remember, this is the triangle that we are supposed, I want you to see this properly this here. This is the triangle that we are referring as AED. Okay, so far we do not have any, we just have an angle, this angle 43 degrees. If we had this side, let's say we have got this side AE, and we also have this side ED, we can calculate the area, because we know that the area of a non-right angle triangle is given by half AB sine theta. So it's gonna area it's half AB sine C. We've got the area. So in this case, we do not have the sides which are creating the angle of 43 degrees. So we're supposed to calculate AE and calculate DE. If possible, that is what we're supposed to have, AE and also to calculate DE, okay? So let's calculate AE first. AE, we can use this triangle because we've got a right angle triangle, remember? This is going to be opposite according to 61 degrees, and here you've got adjacent. So you're supposed to take the ratios from SOHCAHTOA. Which ratio can you use? From your SOHCAHTOA here, the SOHCAHTOA opposite and adjacent is for tan. So you know that tan of theta is equivalent to opposite over adjacent. So tan of the theta, which is 61 degrees. So you've got tan 61 degrees equal to the opposite, which is the one that you want to calculate, AE, over the adjacent, which is 28. So this is what we have. So you can cross multiply to find AE. That's 28 tan 61 degrees. Okay, so AE is equal to 28 tan 61. So that's 28 times tan 61 degrees, which is going to be 50,513, something like that, 50,513. Okay, so we've got 50,513. The units is meters. Okay, so that's what we have for now. If we have to cross check here, because now we've got AE, so this side we have it. So I'm just going to write it aside. That's 50,13. 50,513. So now we can calculate ED according to this one. We've got this angle. Which part can we use? Actually, we can calculate these angles. We can have these angles. Remember, here it's 90 degrees and we've got 43 degrees. So 90 minus 43 is going to be this other angle here from angles that we have. So it's 90 minus 43 degrees. So that's 43 degrees, which is going to be 47 degrees. So here, this angle is 47 degrees. We can calculate angle C, knowing that angles on a straight line, angle in a triangle, they add up to 180 degrees. So subtract 47 and 56 from 180. So 180 minus 47 plus 56 is going to give us 77 degrees. All right, so this angle is 77 degrees. Why am I finding angle C? Because we've got angle C opposite to the side that we want to calculate. We have got 56 degrees opposite to 28 meters. So that means we can apply sine rule to calculate DE. All right, so to calculate DE, so here we are supposed to calculate DE. So apply sine rule. We know that it's a side, so it's A over sine A. A over sine of A is equal to B over sine of B. So that's A, the side that you want to calculate, which is DE. So we are going to have DE over sine the angle that is opposite, which is sine 77 degrees, is equal to the other side, which is 28 over sine 56 degrees. So that's what we have. So to find DE, we can multiply by sine 77 both sides, multiply by sine 77 both sides. Okay, so this can cancel. We have got our DE being equal to 28 sine 77 degrees over sine 56 degrees. Okay, so that means our DE from this part, we are going to have 28 sine 77. So it goes 28 sine 77 over sine 56. So this is sine 56 degrees. So that's 32.908, something like that. 32.908 meters. So we put DE. All right, so having our DE here, we can just indicate our DE. That's 32. Okay, let's check here. It's 32.908. Okay, 32.908 32.908 meters. So we have the two sides and the angle that is in between of 43 degrees. So that means we can actually calculate the area. So our area is going to be half AB sine C, which is a half times 50,513 times the other part, which is 50 point. Okay, let me just write it here. So we have got our area being equal to half multiplied by 50,513